Welcome! In this series of short videos, we will look at topics for the PowerBasic Console Compiler. Today we will look at how to get and set the size of the console, and the positioning of text from within your application. The PowerBasic Console Compiler has a number of commands that are specific to the operational and manipulation of the console itself. And it's those we're going to look at today. The application we have before us here is a very simple PowerBasic console application. The first line of code, con.color, is setting the foreground and background colors. The command has two mandatory and one optional parameter. The first parameter is the color of the foreground. You have a choice of 16 colors, ranging from black to intense white. In this application, I'm setting the foreground color to 10, which is light green. If you don't want to change either the foreground or the background color, you can use the value -1. That will leave the color unchanged. The third and final parameter for this command is count. This is optional, and if it is used, it causes the color attribute to be applied immediately to that number of characters, starting at the current cursor location. So this first command will set the foreground color to light green. We are then printing to the console this piece of text, console sizing. If we run our application now, you will see the console comes up and the printing is in light green. It's printing the words console sizing, and then press any key to continue. Pressing any key on the keyboard will complete the application. The size of the displayed console is dependent on its configuration. There are commands within the console compiler to determine what that is currently set at. So what we're going to do is we're going to pull back from the console the size of the screen in rows and columns. First, we will declare two variables to hold that information, and then we will populate those variables using the con.screen command. Con.screen will first populate the row height and then the column width. This will tell us how many characters will fit in to the width of the console and the height of the console. We can then print that information out to the console so we can see what it's set as, quite simply by using the con.print command. If we run the application now, we will see our default size for our console is 80 characters wide and 25 characters high. However, if this is insufficient for what you wish to do in your console application, you can increase or decrease it. Many console applications run in the background and there is no one to watch what's happening on the console. In fact, some of these background applications may be run without a console at all. However, there may be times, especially when you're debugging the application, that it's useful to put information out to the console so you can see what the application is currently doing. However, for a client-facing console application, you will want to give some feedback to the user to indicate what the program is actually doing, and also to give some indication of how long it is to run. So we will now set the width of the console from 80 characters wide to 100 characters wide. We can do that quite simply by using the con.screen command, which takes two parameters, the row height and the column width. As we're going to be printing out the size of the console, let's create a little macro to save us a bit of typing. Macros are a very useful construct, usable in both the console compiler and the Windows compiler. At compile time, any reference to the mconsole size will be replaced by these three lines of code before it compiles. So we can use this to print out to our console the size of our console itself. If we run the application now, we will see that it's telling us that the console is 100 characters wide and 25 characters high. However, you will see that in changing the size of our console, it has effectively blanked out what was originally on the console itself. If we put a delay in the code between the time when we printed out the original size of the console and the time when we resized it, if we run that application now, you will see it prints out the original size of 80 by 25, and then 2 seconds later, the console is redrawn, made larger, and then set on screen to show 100 characters wide by 25 characters high. So it's important to note, if you're going to set the size of the console, expect what's on the previous console to be erased. So this command pulls back the console size in the number of characters. We can also pull back the size of the console in pixels. If we define two variables for the X and the Y size, and use the con.size command to send the value in pixels to these two variables, we can then print out those values on the console. And we can see here that the console is currently 1733 pixels wide and 939 pixels high. So can we do more with the console? Obviously, the console is limited by the physical size of your monitor. The size we're showing at the moment of 100 by 25 is limited by the size of this monitor. If I want to make it larger, we can put in a virtual console. The virtual console will support multiple lines beyond the size of the physical window, and will automatically give you vertical scroll bars or horizontal scroll bars to support this. So we're now going to set up a virtual size console. Again, we'll dimension two variables, one for the column width and one for the row height. So we're going for 100 columns wide and 100 rows high. And the console set virtual command will take these two variables and set your console accordingly. So I'm going to set up another little macro to print out the size of the virtual console, which is using a different command. This is using con.virtual to pull back the size, row and width height for the virtual console. So we'll use that to print out on our console the size of a new virtual console. And there is our virtual console, 100 characters wide and 100 characters high. Now that we have 100 rows of information, as you will see, there is now a scroll bar on the right hand side of the console, which can be used to scroll down and up. This allows you to have a virtual console much larger than the standard 25 rows. And if you're putting a large amount of information to the console, it will allow your user to scroll forward and back to see information that has been displayed. So having set our virtual console, can we now print some data out to the console? When you're using the con.print command, it will print a line out to the console and then will print on the next line after. So we should get line 1 and line 2 on two separate lines. If we run that code now, we will see line 1 and line 2 are printed out to the screen. If you wish to print line 2 on the same line as line 1, simply place a semicolon at the end of the first line. If we run that code now, you would see line 1 and line 2 are now on the same line. The semicolon forces the application not to put a cabbage return line feed at the end of each line. However, there may be times when you wish to print on a specific location on the screen rather than on the next available line. We can set this in the application by using the con.cell command. We've created two local variables, row and column, to hold the values. We're setting the row to be row 10 and the column to be column number 1. And we're using con.cell with those two variables to set our location to row 10 and column 1. We can now print some new data to the console at this location. And I'm using the semicolon at the end of our command to ensure that the cabbage return line feed is not executed at the end of the print statement. If we run that code now, as you will see, the words new data are now on line number 10. As we put a semicolon at the end of that print command, the next text to be printed at the console will be printed on the same line. Removing the semicolon would allow the text to be printed on the next line. However, now that we have a mechanism by which we can print to any location on the screen by the X and Y character coordinates, we can now print on a line before line 10. So we can print on line 9 and column 1. If we run that now, you you will see we're getting old data on line 9, new data on line 10, and the press any key to exit is appearing here on line 9, as that's where the current cursor is now located. We can also take the opportunity for printing further along on line 9. And we can change the colour we print with quite easily by using the con.color command. So here we are printing to row 9, column number 10. And we're printing the words extra data, but we're printing it in colour number 5. If we run that code now, you will see that the text extra data is now printed in a magenta colour. And every piece of text generated after that will be in the same colour. So if we wanted the press any key to exit to appear on a line below all the text we've currently done, we can use the same approach. We can set the column position to be row 20 and column number 1. We can also set the colour back to green. And there we have it. So in summary, what we've done today is we have taken our standard console and we have amended its size. We have also set up a virtual console to allow scroll bars to be initiated so we can scroll up and down within the console itself. So a large amount of text can be maintained on screen for the user to peruse. We have also used the cell command to target the area to which we wish to print on the screen. So we can print on any row and any column, and we can amend the colour that appears on screen. So using this approach, you can have complete control over what is printed on the console and where on the screen it appears. This would allow a console screen to maintain a report of real-time data generated during the running of your application. There are many more other console commands which we can use to manipulate the console. However, we'll leave that for another video. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.